Alright, Chem team, here comes a little intro on density and as well as a little review and building upon what you've learned about for SigFigs or significant figures in class. And first off, density is an intensive property, so we're going to learn a lot about things that are going to be called intensive or intrusive properties, and that means that they're not going to change based on the sample that you get, so no matter where you get the sample, the property remains constant. So density is a measurement to tell you how compact all the particles are. So if you look at the atoms or the molecules inside of a substance, how closely packed together they are is the density. The way we find that, and you'll see this in your reference table once you get it, is that density is mass divided by volume, and you'll see it in the formula as capital D equals M over capital V. And the way we're typically going to measure these is that you're going to typically see it as a grams per milliliter. You could also see kilograms per liter, or you could see grams per centimeter cubed, which is the same thing as a milliliter. Alright, so if we take a look at a sample here, we're going to apply some of our geometry knowledge that we've learned from the past. If the mass of a block is 205 grams, what is the block's density? So the first thing I want you to do is, as you read this, you know right away the question is asking you what is the density. So whenever you get one of these problems, we're going to learn a lot of formulas this year. Write out the formula for the equation that you would have to use. And so right away we know that we're going to be using the density equation. So we know we're going to need at least two of these variables in order to solve the problem. And if we look at our problem, it's telling us that the mass of the block is 205 grams. So write out each one that you know. So we know mass equals 205 grams. If we're looking for density, that means we should also have volume somewhere in the problem. Now we don't have a value in the wording of the problem, but if we look at our diagram, we have a length, a width, and a height. And we know that if we want to find the volume of a cube, since we're dealing with a block here, we would do length times width times height. So therefore we're going to take all three of these values and multiply them together. So we have 3.0 centimeters times 5.0 centimeters times 4.0 centimeters. So we're going to multiply all three of those together, and what we get is an answer that is 60. And since we are multiplying 3 centimeters together, we treat our units like variables in algebra class. So that's like x times x times x, or centimeters cubed. So we'll put that up there. You can also rewrite this, as soon as you see a centimeter cubed, you can also rewrite it as milliliters. So 60 centimeters cubed and 60 milliliters are technically the same value. It's just a different way of measuring it. Okay, so now our next step, we're going to plug what we know into our equation. So we know that we have mass over volume. So if we plug in our values, we have 205 grams divided by 60 milliliters. So we punch that into the calculator, and the answer that we get when we punch it in is we get this number of 3.416666, and it keeps going on and on and on. So you have 3.41666 grams per milliliter. Now, our discussion on SigFigs today, the reason that we use SigFigs is because we can only show an answer or value that is as good as our least precise measurement. So we have to go back to our problem and actually look at the measurements that we created or we were given. So the measurements that we actually have in the problem are 205 and then our length, width, and height. So if we look at all those, we can see that the 205 has 3 SigFigs, because you have the 2 on the outside and a 5 on the outside. So if we were to, that means we're going to sandwich the 0 in the middle. That gives us 3 significant figures in our mass measurement. And then if you look at each one of our length, width, and height measurements, they're all 0.0, and that 0 is at the end of a decimal or end of a fraction. So that means that 0 is significant, and the 3 in front of it is that 0, the 5 in front, that 0, the 4 in front. Those are all significant. So each one of these measurements has 2 sig figs. Now we're only as accurate, or our calculations are only as good as our least precise measurement. So our least precise measurement out of all of these is going to be 2 sig figs. That means we're going to take our answer or value that we got up here and we're going to round it so that it has 2 sig figs. And so what we're going to do is we're going to take that 3 and then we're going to start moving to the right 2 spots. So 3 and then 0.4. That means right after this point here is where we're going to round. So we look after the 4, that's a 1. So that tells me we're going to keep that 4 value, not going to round it up to 5. So our actual answer that we would record with 2 sig figs is 3.4 grams per milliliter. Okay, so whenever we look at a problem, your value is only as good as your least precise measurement. So the general rule is you find your worst measurement and round your answer to that. Typically, our measurements, we try to make them to 3 sig figs, but you'll see problems like this occasionally that are going to have 2 sig figs. So round according to the measurements that are given to you in your problem. Let's take a look at one more example. So the second one, what's the density of the fluid inside a graduated cylinder? So again, what's the density? We're looking for density. Write out the equation that you're looking for. So we know that density is mass over volume. And then it doesn't give us any values, so we're going to have to look at our diagram to get as much as we can. So right away, I'm looking at I have an empty grad cylinder and a filled graduated cylinder with a liquid. And I can see that the mass of empty and the mass filled. So in order to find my mass, I'm going to have to do a little extra work. I can't just take it here. If I know that empty is 250 and filled is the graduated cylinder and the liquid is at 1300, I can subtract these two. To get my mass. So if I subtract those, I end up with 1050 grams for my mass. The volume, in this case, we can read our diagram here and we see that the liquid level is going right up to the 1000 milliliter mark. And we can say that with confidence within that one's place. So actually, this value here has 4 sig figs. We would put a line through that 0 at the end to tell us that we are precise enough to this place, this one's place. So we're at exactly 1000 milliliters. Alright, so now that we have both of our values, we're going to plug them into our equation. So we know that density is mass over volume, so we're going to have 1050 grams divided by 1000 milliliters. And so as we look at this, if we divide it out, we get an answer that is at 1.050. And again, go back to what is your least precise measurement. So if we look at our measurements, we can see that our mass measurement here has 3 sig figs because the 0 on the end is technically not significant. So right here is where we would actually cut it off, so it has 3 significant figures. Our volume measurement is the entire thing, so that we know that when we measured looking at our graduated cylinder, we were precise or accurate to that one's place, telling us that all 4 of these are significant. So our least precise measurement has 3 sig figs, so that means we're going to round this to an answer at 3 sig figs. So 1, 2, 3. We're going to cut it off right here. So our answer is actually 1.05 grams per milliliter. And so just like we talked about, your units are like variables in algebra class. So x over y, grams over milliliters, same idea. They don't cancel out unless they are the same unit. And so you couldn't round this to 1 because your measurements are actually precise enough to get 1.05. So your final answer for this is 1.05 grams per milliliter. As always, bring questions to class. We'll do more practice as we work through these together.